Coding can be a pretty complex process, and I don't just mean the act of you writing code, but the whole process of transforming your code into something that can be run, into something that a computer can make meaning out of. Now, we are generally aware of the process of compilation, that is of course turning your code into something a machine can execute, but before that, there is actually also another step that, well, sometimes we are not aware of, called pre-processing. Today, let's look at that, and let's take a look at that in the context of 4 different programming languages to see how powerful pre-processing can be. You're watching another Random Wednesday episode on 0612 TV. Hello and welcome back to another Random Wednesday episode. So, code pre-processing. What is it? Why is it useful? In a nutshell, code pre-processing involves having some software go through your code first. This isn't compilation, this is just poking into your code as text and tweaking it up in a certain way to generate more code that is still in a textual form. Remember, this is distinct from compiling or running your code. It is tweaking it up as text so that when it is actually compiled or run, things, well, work in a better way. To understand this better, we're going to be looking at this in the context of 4 different programming languages, namely C, well, nice traditional programming language, Sass, which is a CSS preprocessor, Flask, a Python-based web backend, as well as PHP, another very commonly used backend. And we'll just see sort of some different contexts in which preprocessing can make life extremely useful. Let's start off with C. Now, if you've ever worked with C code in the past, you'll know that we usually open the page by writing certain statements that are preceded with a hex symbol. Usually these are include statements, sometimes we use things like define statements as well. These are what is known as preprocessor directives. That is, code for the preprocessor to read. That stuff never gets around to the compiler. Your compiler never actually sees these statements. Instead, the preprocessor jumps in and replaces these with other code, which in turn gets compiled. Let's start with the simplest include statement. Essentially, when you're saying something like include standard IO, what happens is your preprocessor goes to that file, grabs its entire contents, and simply plops it in place of that line. That's right, your small page of code actually now becomes a very large document because, well, that stuff, which is quite large, gets substituted in. Unfortunately, it's not quite as easy to visualize what's going on with, include statements. So instead, let's take a look at define. Now, usually define is used to, well, define some constants up there, right, and they end up being used just like variables. Let's take a look at how this can be useful and what a preprocessor really does to the define statement. Here are constants at their simplest. At the top of your code, simply have a define statement which says, well, a constant name and the value it's supposed to hold. And then all you need to do is to let the preprocessor do its work. And what it gives you back is, well, this. The value is actually substituted in place. Notice that there is no more reference to the so-called variable name, right? You no longer see the text a constant anywhere on this page. The preprocessor has already done the substitution. You can even use this in the context of, say, math. So if I were to put the constant plus 2, well, it's not going to evaluate that. Instead, what it's going to give me back is 3 plus 2. Of course, this isn't actually limited to numerical values. You can basically put in anything. For example, you could define an expression, and what you put in there could be something potentially complex. Say, well, let's do 3 times 2 plus 5. Now, let's create an integer that takes on the expression, like so. Again, when we actually let the preprocessor work on this, it is not going to evaluate that statement. Instead, it is simply going to substitute it in place. Now, in the context of the C preprocessor, there are also several advanced features that, well, we'll just take a very quick look at. There are features that actually perform logic. Like in this case, we actually have a statement called ifdef, which means if this macro has actually been defined, then do something. Now, we haven't defined a macro called showCode, which is why if we were to actually pre-process this page of code now, you will find that there is nothing inside main. Because the if statement has actually failed, the code in between doesn't come out at all. Now, let's add another define statement at the top of this document, saying define showCode. And now, when we run this, you will find that, well, the code here appears. So in fact, the C preprocessor does more than substitution. It can also perform some kind of logic, and if you set it up right, it can even do things like loops. Of course, it's not really a very conducive tool to do something like this, but if you need such functionality in a pinch, you could actually achieve it. And there you go, that has been the macro or the define statement in C. Now, we've only seen it used in the context of substituting constants or very simple expressions, but as you can imagine, you could, potentially write a whole bunch of C code, stick it in a macro, and have your preprocessor actually substitute it in at the right places during compile time. Obviously, that's a very bad idea. It will work, don't get me wrong, but it's just a pain from a software engineering perspective. So yeah, that's not something you want to do, even though, well, you technically could. So that has been preprocessing in C. That is one way preprocessors can be used, but there are programming languages that are entirely just preprocessor languages, and for this, we'll be looking at Sass. Sass stands for Syntactically Awesome Style Sheets, and the whole point is, it's there to extend CSS, which are of course your cascading style sheets, or what give your web pages some style, some aesthetics. The interesting thing about Sass is that it's there to basically do things that CSS cannot. You write Sass code, and after running the interpreter, you generate CSS. It duplicates up whatever needs to be duplicated, it does whatever substitutions need to happen. At the end of the day, you get CSS. So this is a very interesting sort of different context of applying a preprocessor. Let's take a look at how Sass works. Now, right off the bat, there are several interesting things about this small piece of Sass code that I've written. Now, for the most part, it looks like CSS, but it gives you some features that you don't normally have. For example, variables. Now, if you've done a lot of CSS, you'll know how much variables could have made things easier, but it's not in CSS, and that's one of the things that Sass changes. This one is particularly interesting because, well, if you have some elements on the page, chances are you would want them to rely on a base width. So what we could do is we could set up a base or a standard width in which, well, the other elements can simply do some math, to make it relative to that standard width, and, well, that defines the actual sizes. So, well, before we look at this part, right, let's ignore that first. Let's go ahead and run the Sass preprocessor. Now, the syntax for this is a little bit different, but, well, it works exactly as you would expect. So let's get the file in, and as you can see, well, there is no more reference to the variable. It has just been turned into valid CSS, but these numbers actually come from the evaluation of the math here. Of course, there are many more, interesting things you could do. For example, this is an array. This is actually a loop that goes through the array and generates a few pieces of CSS, substituting in the values that actually come from the array itself. So very, very interesting stuff, right? Basically what happens is that, based on the fact that we had 4 colors, is able to actually generate 4 CSS selectors with the correct CSS substituted in. Of course, those were just the basic features. There are many more advanced features within Sass that, well, can allow you to express your intent even better. For example, you can use functions. These functions, of course, run as you would expect, right? So if I were to actually run this code, you can see that, well, the square here has been calculated here. Similarly, you could have these things called mixins, which are kind of like functions, but they generate CSS. So the idea is, well, this is like a function, this is the CSS it actually returns, and you can give it parameters like so. Essentially what we're doing here is we have a function that basically themes our site, but it takes in a size multiplier. So how we do it here is that, well, for H1s, right, our main headings, we want the multiplier to be larger, we want the text to be larger. For smaller headings, they have a smaller multiplier. After the preprocessor does its magic, you can see that the font size has been calculated accordingly for H1 and H2. So yeah, I think you get the idea. Sass is very interesting because it is a dedicated language. It only does preprocessor work, and at the end of the day, it churns out CSS. Its job is to allow you to achieve more by writing less. And there you go, that was Sass in a nutshell. Hopefully you can see the contrast between this and the C preprocessor. It's basically a whole new language that gives you a lot of additional expressive power. It's not just a little convenience tool like, what C is. You can actually do more powerful things using Sass, and ultimately, again, it gives you CSS. Now, interestingly, up to this point, the two preprocessor languages we've looked at are technically optional. You could manually copy the contents of standard I/O into your program. You could basically never use C macros, or in the case of Sass, you could just write plain CSS, right? Just duplicate up your code as necessary. You can express everything without using the preprocessor language at all. We're now going to move into the territory of what web backends, what servers actually do to serve up web pages. And in this case, they still do preprocessing, even though the terminology tends to be known as templating instead. Here's what I mean. Let's say now you, log on to the main page of YouTube, and assuming you have an account, your profile picture appears in the upper right corner. All the videos that appear on the page have been handpicked based on your past viewing, history, as well as your preferences. Well, at least to the extent that can be determined by Google. What this means is every person who logs into YouTube sees a different page. And what this means is on the back end, the page needs to be constructed. As you can imagine, the page has to start off as, basically an empty structure in which little placeholders have been set saying that, hey, replace this with the user's profile image, replace this with their subscriptions, replace this with a tag they may be interested in. It starts off as a blank slate like that, but all the things that are consistent, for example, the YouTube logo, the search bar, all those are already in place. This is basically a template, and a preprocessor can come along, take a look at who it is that's logged in, retrieve whatever is needed from the database, and populate all those components. Now, there are many backends that can do something like this, and we're going to look at a more modern one first, and that is Flask, written in Python. Essentially, what you could do with Flask is you could write a HTML page that is of course a web page, but on top of that normal stuff, you could also write certain statements that basically give instructions to the Flask preprocessor, to the templating engine. Let's take a look at a small example. We are obviously not going to be rebuilding YouTube. Instead, let's do a very simple example that goes to a database, fetches a few lines, and plops it on the page. We'll then tweak up the database and you'll see that, the values have changed. Let's take a look. This is a Flask template. And if you're familiar with HTML, you will see that, this seems to be HTML with a little bit more tagged on. That's exactly the point. Essentially, this works in conjunction with Python code, which I will show you in a bit. The idea is the Python code populates variables like this. It is in turn used in a loop, and essentially this is a loop. And it will generate as many paragraphs here as there are entries in data, which again we will look at next. For each entry, we will show, one item in bold, another item. The Python code looks something like this. Essentially, it connects to a database, right? It's a very simple database that I've just populated with some sample values. It's going to pull values out of that database. And essentially what it's going to do then is it's going to render that template. It's going to render out this page. And not only that, it's going to send over this information. So the thing we've pulled from the database is actually stored in this variable called items. We're going to assign it to the variable on the page called data, which, if we switch back to the template, is this variable here. So hopefully you can see how everything pieces together. You have a template that expects some variables. You have code here that populates the variables and then renders out the template based on those values. Now, there is no better way to demonstrate this than to simply run this code. So what I'm going to do is I'm going to go ahead and fire up this program, right? And what it's going to do is it's immediately going to step in and set up a web server. All I have to do is to point my browser to this address and, well, I will see the page. So let's try that. So what I've done is I've gone ahead to connect to this site, right? Which is of course the site that was specified, by the server. And what you see are not the loop stuff. What you see is actually the values coming back from the database. Now, what I can do is I can actually view source on this page. And as you can see, it has actually repeated this bunch of code as many times as there are items in the database. That's essentially what the preprocessor has done. It has actually run some logic, and it has actually generated all these values. I'm going to load up the database in this program called an SQLite browser, right? Basically, this pokes into the database itself to show you the values. What I'm going to do is I'm going to add a new record. So I'm going to click on a new record here. I'm going to add, say, I don't know, peach, right? And let's put that at, I don't know, 90 cents. I have obviously no idea how the fruit market works, but never mind, I've written the changes now. We are back in our browser. I'm going to hit the refresh button, and notice the additional entry has immediately appeared. So yeah, essentially what we've created here is a dynamic page based on a dynamic data source, in this case a database. This is what gives web backends so much power. Instead of serving up a static HTML page like this that cannot easily be changed, you just use a template. HTML is generated on the fly based on the data source. And there you go, that was Flask templating. And as I've mentioned, it's a little bit newer than, well, quite a lot of web server technologies out there. One of the more classic ones is PHP. And I've wanted to bring up PHP, after Flask to sort of show you the contrast between the two, because PHP is essentially a tool that is built for the same purpose. It's also a backend language. It also constructs a page, in the exact same manner, in the exact same use case as I mentioned previously. But there is one difference, and that is in Flask, you write mostly Python code. The template itself, the HTML file, just contains a small amount of logic, enough to say how to substitute information. So you can sort of picture it like there is a Python component and there is a template component, the actual preprocessor stuff. They are separate, but they talk to each other. PHP, on the other hand, is different because everything you write is preprocessor code. You don't have a separate template and a place for you to write your logic. In PHP, it's all together. You express everything in that same language. So let's do the exact same example, but now using PHP, and we'll see how different the approach is. This is the exact same program as we've seen previously, except now we've implemented it in PHP. In Flask, we've had to, do our database stuff separate from the actual template itself, but now it's all in one. Again, if you're familiar with HTML, this should look kind of familiar, but at the same time, kind of different. Essentially, what we have now is PHP code that, connects to the database and pulls the information. Again, I hope you can draw parallels between this and the Flask example. Then in the body of the page, we have a while loop that goes through the contents of the database, the stuff that comes back from this query. And again, we are constructing paragraphs as we move along. This code will of course be repeated as many times as necessary. I already have the server for this running, so let's take a look at the page itself. Alright, so let's go ahead and connect to the right file. And as you can see, PHP does its thing. Again, if you were to do view source on this page, you would see that, more or less the same kind of thing is being constructed. well, barring some additional spaces, which I'm sure is because of poor coding on my part. But that's not important because this code is now not really for a person to look at. What's more important is that, well, the code here is able to generate the results we want to see, namely this stuff. Now, again, I'm gonna go poke into the database to prove to you that, well, there's no tomfoolery here. So here's the database itself, right? The data is here. This is actually the same SQLite file I've taken from the previous example. I've just copied the file into this folder now. And again, we can add a new record. Let's go with a different fruit this time. Let's do grapes. Let's make it $1.50. Write changes. And now we can go back to our browser, refresh, and see the new value appear. So yeah, it's the same kind of preprocessor magic. It is code that generates more textual code. And there you go, that has been PHP. Hopefully you can see the difference between the Flask method, which separates the main logic from the template, versus PHP, which lumps it all together. Incidentally, a lot of people actually dislike PHP. Now, there are many reasons why that is so, but this particular mechanic could be one concern as well. You see, the problem is you're sort of mashing everything together. All your logic, all your actual display stuff, that could make your code kinda unreadable. There is no separation of concerns, and yeah, as a result, that makes it quite hard to maintain. You have to know and actively apply good programming practices to write a good PHP application where there is a proper separation of concerns. So yeah, that is one possible source of criticism for PHP. Interesting to see that, well, the approach can sort of create a very different programming experience. But well, returning to the topic of preprocessors, today we've looked at 4 of them: C, Sass, Flask, and PHP. And we've seen how they're all sort of different approaches to different problems, but all using the same underlying concept, and that is using some preprocessing on the text code to generate more text code that has its whatever meaning that you've intended. It is a very interesting phase of the programming process that maybe we don't give a lot of thought to, especially when we're writing something like C. Of course, the same concept becomes a core component in something like PHP. But yeah, there you go. That's preprocessing as a concept used in so many different contexts. I hope this video hasn't run too long. But yeah, that's it. Thank you very much for watching. Hopefully you have a better understanding of this concept now. But again, that's it. Until next time, you're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.